Hello guys, today we will be solving the fourth problem from my LeetCoding challenge. The problem's name is number complement. We are given a positive integer and we have to output its complement number. The complement strategy is to flip the bits of its binary representation. So basically if we look at the examples, the answer for 5 is 2 because the binary representation of 5 is 1, 0, 1 and its complement is 0, 1, 0. We're flipping every single bit. So if we flip 1, we will have a 0, and if we flip 0, we will have a 1. That's why the complement of 1, 0, 1 is 0, 1, 0, and the answer is 2 because 1 and 0 is the binary representation of 2. And the same strategy will work for the second example. So the given integer is guaranteed to fit within the range of a 32-bit signed integer, and we could assume that no leading 0 bit in the integer's binary representation. So how can we solve this problem? The first idea that came to my mind is to create a vector or maybe a string where we will store the binary representation of this number. And then if we have this vector or string, we can flip every single bit and then construct a number from its binary representation. But we can also use bit manipulation to solve this problem. The only thing we need here is to find the rightmost one bit. So how can we find this bit? We can iterate through all of the bits, starting from the largest one, and then see if the is bit equals to 1, then we find the rightmost one. We can store it in a variable, and then starting from this rightmost one, we can construct the whole answer. So starting from this rightmost one, we can flip every single bit and use bit manipulation to construct an answer. So let's do that. Let's call our variable rightmost one. And what will we do? We'll iterate through all of the bits, starting from the largest one. So, and here I'm using a binary manipulation to find the is bit of an integer number. So what will I do? I will shift to the right my number by I. And this one will shift number by I, yeah. And then I'll get a binary end with a 1. So basically, if the is bit of integer was 1, then this thing will give me 1. And if it was 0, this thing will give me 0. Basically, it's what I need. So if the is bit equals to 1, then I find the rightmost one. And that's why the rightmost one would be equal to I. And then I have to break. So basically, it could be that I didn't find the rightmost one. And let's put here -1 then. Okay, so, oh, I see. It would be better if we put it 0, here 0, because if the number is 0, we have to return 1. And if we put here -1, we will return 0. So let's define a new integer. Let's call it answer. So for every bit starting from the rightmost one, what will we do? We will see if the is bit is equals to 0, we will use the same strategy. So if the is bit is equals to 0, it means that this bit should be 1 in a resulting integer. So basically, I'll use a binary OR to set this bit. And I think that's it. And after all of this, I should return an answer. So what am I doing here? In this for loop, I'm finding the rightmost one. If I found the rightmost one, I'm starting from this rightmost one and see if the is bit equals to 0, then I'm setting this bit in the answer. Because if the bit is 0, its complement is 1. Okay, let's try to run this code, make sure that it works for the sample test case. Cool, it works, and let's submit it. Cool, it got accepted. So if you have any questions, leave them in the comments below. See you in the next videos. Bye.